Good morning or afternoon, depending on when you are watching this video. I hope you guys have dried all your tears since I'm not there with you physically today, but don't you worry, notes will still go on. Cue applause from class. All right, so today is the 17th, and we are graphing inequalities today. And so a lot of this will be similar to just graphing a normal line, but we're adding those less than, greater than, less than or equal to, or greater than or equal to signs today. So let's start off with some steps. All right, so hopefully you are writing this with me in your own notebooks. So if you don't have your notebooks out right now, maybe I'll give you a little time to get that out. All right, so our steps for graphing inequalities. The first step is to isolate y. Isolate y. All right, so what that means is you're pretty much getting y by itself. You may have to solve the inequality for y, and y'all know how to solve inequalities. We've done that before. All right, and step 2 is to plot the y-intercept. All right, you're plotting this y-intercept on the graph. All right. Step 3 is to use slope to do rise over run so that you can find your next point, plot on the graph so we can make a line. So use slope to do rise over run. Use slope, use slope to do rise over run. All right, step 4. This is when it gets kind of new, a little crazy, so buckle your seatbelts. Step 4 is to choose whether you're going to have a solid or a dotted line. Choose a solid or dotted line. All right, and the way you decide that is depending on what inequality sign you have. All right, so if you have a less than or just a greater than sign, that would be a dotted line. So let's draw a little graph here, our little table. A dotted line would mean you have a less than or a greater than sign in your inequality. All right, and then you would choose a solid line if you have less than or equal to or greater than or equal to. All right, so what I mean by a dotted line is on a graph, your line would look like this. It's dotted across, okay? But if you had a solid line, it would just be a normal line like you've been doing. Just like that. All right, and then our final step, this is the fun part, is to shade under or over. All right, so we will shade our graphs, our inequality graphs, above the line, over the line, or under the line, depending on the inequality sign we use. So let's draw another table here. You will shade under if you are using a less than sign or a less than or equal to sign. You will shade over if you're using a greater than sign or a greater than or equal to sign. All right, so what that means is if you were to have an equation, let's say with a solid line like this, and your inequality has a greater than or equal to sign, you would just shade above this line just like that. So this is where if you have some fun little colors, you can always bring those out. Make your math notes fun and colorful. All right, so hopefully you have these 5 steps down, and I'll give you a second maybe to get these written down. Is there an awkward pause in the class right now? All right, I'm moving on. I would ask it for you to yell out if you wanted me to stop, but I'm sitting in a room alone, so nobody here to yell out. All right, let's go. All right, so let's look at our first example. All right, so our first example is y is greater than 1/3 x plus 2. So if you look back at the steps we just wrote down, the first step said to isolate y. And here, y is already isolated, so that first step is already done for us, so we get to skip on over to the second step. Step 2 is to plot the y-intercept. So this inequality here is in our slope-intercept form. Can you see how we have y is greater than a mx plus b? Okay, so it's in our slope-intercept form. So we can just look for b in this inequality, which would be 2. So if you'll just write b is equal to 2 so we know. All right, so let's plot this y-intercept. So that means we look at our y-axis and we see where our y value is 2, and that would be right here. Okay? Step 3 said to use slope to do rise over run. So we're going to use our slope, which is m equals 1/3. And our rise is 1, our run is 3, and we'll use that to find the next point on this line. So we will rise up 1 over 3 and plot a point. All right, so now we have 2 points and we can make a line. But before we do that, let's look at step 4. It says to choose a solid or dotted line. Okay, so if you look back at your table you wrote down, we have a greater than sign. So, do I want a solid or a dotted line? Miss Patterson, you want a dotted line. Great job, imaginary student. Yes, so you will have a dotted line that goes through these 2 points. So that'll look something like this. All right, so that's what our dotted line will look like. All right, and then the last step here is to shade under or over. All right, so again, look at that table that we wrote down earlier. And we have a greater than sign. So if you see that table, what do I want to do? Do I shade under the line or do I shade over the line? Miss Patterson, you shade over the line because it's a greater than sign. Great job, imaginary student number 2. Yes, we are shading over this line. So you can just take your pencil or pen, whatever you're writing with, and just do a little shading, just like this. And this is showing, this picture here, this graph, is representing the inequality y is greater than 1/3 x plus 2. So we're showing the solution here on our graph for this line. Since it's greater than 1/3 x plus 2, we shade everything above that line. All right, so the next thing I want to do here is I'm just going to plot 2 random points. So this first point I'm going to plot is -3, 5. And I'll write this right here, -3, 5. And the second point, let's do 2, -2. Okay? Now, let's think about what is the difference between these 2 points here. All right, so hopefully maybe you see one of them is in the shaded area. All right, the area that we had shaded earlier. And then the other one is in the non-shaded area. It's below the line. All right? So, I would ask you if I were there, which one of these points would you say is a part of the solution to this inequality? Okay? So, the answer to that would be the one that's in the shaded area. All right? So this point right here, this is a solution to this inequality because it's in the shaded area, all right? So I'm going to write solution under this negative 3, 5. All right, and then the other point, this one right here, it is not in the shaded area. So 2, negative 2 is not a solution. On your class cake today, you'll be asked to identify points that are solutions and points that are not solutions. So you need to know that a point that is in the shaded area is considered a solution to the inequality. A point that's not in the shaded area is considered not a solution to the inequality. All right, so our second example is 2x plus 3y is less than negative 3. So if we go down our steps, step 1 is to isolate y. In this case, we will need to isolate y. And this is just like an equation in standard form that we're solving for y to put into slope-intercept form, okay? So it's just like we've been doing for the past few weeks, or last week, I guess. So I'm going to draw a line here. And hopefully I can maybe fit this on here. We may have to draw a little crooked line. All right, so if I want to get y by itself, the first thing I would do here is subtract 2x from both sides. All right, so that cancels out here, and we're left with 3y is less than negative 2x minus 3. And I still need to isolate y and get y by itself, and the way I do that is divide by this coefficient of 3 to each term. And we get y is less than negative 2 over 3x, and then negative 3 divided by 3 is minus 1. I hope y'all can see that. All right, so now we have isolated y. It's now in that slope-intercept form. So our second step is to plot the y-intercept. And so here we can tell that our y-intercept, or the b, is negative 1. Okay? So let's plot that on our graph right here. And then the next step is to use slope to do rise over run. So m here is equal to negative 2 over 3. So our rise is negative 2, which means we're going to go down 2 from this point. And then our run is a positive 3, so we're going to go to the right 3 and plot a point. And before we draw our line, we have to decide, is this a solid or a dotted line? Okay, is this a solid or a dotted line? And I'm just going to pretend that Brendan or Taylor or Sakaya, somebody just called out to me and said, Miss Patterson, it is a dotted line. And you are correct. So let's draw a dotted line through these points like this. All right, so there's our dotted line. That was step 4. Step 5, the fun part. We have to choose to shade under or over. All right, so we have a less than sign. So if you look at the table we just drew, we want to shade under because it's a less than. So under the line, we shall shade. Alrighty. So now we've shaded under this line. And let's talk about solutions and non-solutions, okay? So our first point, let's do this one right here. That would be negative 5, 0. And another point, let's do this one right here, 6, 2. So looking at negative 5, 0, that is underneath the line in the shaded portion of our graph. So we would say that one is a solution. Okay, and then look at the second point. It's at 6, 2, which is not underneath the line, and it's not in the shaded portion. So we would say that is not a solution. I'm just going to have to abbreviate there. Alrighty. I almost asked, does this make sense? But nobody would respond. So hopefully it makes sense. All right, let's look at a couple more examples. All right, number 3. We have x minus 2y is greater than or equal to negative 8. So this again is in that standard form, and we must isolate y. That's our first step to get this into a slope-intercept form. All right, so I'm going to draw my line. And to isolate y, the first thing I need to do is move this x term out of the way. So get out of here, x. And we subtract x from both sides. Cancels out on the left, and we're left with a negative 2y is greater than or equal to negative x minus 8. All right. And then we have to do one more thing to get y by itself, and that is to divide by negative 2 to every term. Oh no. Do you guys hear that? You may not be able to hear it because it's been a while, but we're working with inequalities. And we just divided by a negative 2. So we should have just heard this little ding, 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 because we have to flip the sign. So here's your little warning bell. All right, ding, 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 ding. We have to flip the sign. So it goes from greater than or equal to less than or equal to. Just go ahead and write that down so you don't forget. And that's that little faint bell that should always be popping up in your brain every time you divide an inequality by a negative. All right, so once we do this, we divide by negative 2, we get y on the left. And then we have negative x divided by negative 2. So remember that there is a 1 in front of this x here. So we have negative 1 divided by negative 2, and a negative divided by a negative is a positive. So we're just going to write that as a positive 1 over 2x. And then we have negative 8 divided by negative 2. That again is a negative divided by a negative, giving us a positive. So plus 4. And now we have this in slope-intercept form. All right, so let's start plotting things on our graph. Step 3 is to, or is that step 2? Sorry, step 2 is to plot the y-intercept. So b is 4 in this inequality. So we're going to plot 4, 0, 4 on the graph. So where this y value on the y-axis is 4. And then step 3 is to use that rise over run, this slope, to find our next point. So our slope here is 1 over 2. So from this point we go up 1, to the right 2, plot another point. Step 4 is to decide, do we want a dotted or a solid line? What do we want? And the whole class called out right now, a solid line. Great job. Yes, we have less than or equal to as our inequality sign here. And what we wrote down earlier in that table under our steps is that when we have less than or equal to, that means we're just going to have a normal solid line. Just like this. Okay? So we drew our line through those 2 points. Now we have to decide, do we want to shade this over or under? So do we shade this over or under? We have a less than or equal to sign. And what we wrote on the first page is if we have a less than or equal to sign, that means we shade underneath. It's less than. So let's do some shading right here. Alrighty. So this is what our solution looks like to this. Y is less than or equal to 1/2 x plus 4. All right, we've shaded underneath our line. So let's talk about some solutions. All right, let's do the point -4, 7. And the point, I'm going to do 4, 6. All right, so looking at negative 4, 7, what do you think? Is that going to be a solution or not a solution? And the whole class just said, not a solution, because it's not in the shaded area. All right, so negative 4, 7 is not a solution. All right, and let's look at 4, 6. This one's slightly different. So when we have a solid line, that means every point on that solid line is part of the solution. When we had a dotted line, the points on the line are not a solution. So what I mean by that is, let's look back at one of these. If we were to look at this point right here on our line, since this is a dotted line, it's not in any point on that line is not included in the solution. So this point at negative 3, 1 would not be a solution. But on this problem, we have a solid line. So any point on the solid line is a solution. It is part of the solution. It's included. So 4, 6 is on our line. And so that is part of the solution on the solid line. So this one is a solution. All right. And we have one more. It's the last one. Woohoo! All right, so number 4 is y is greater than or equal to 4/5 x minus 3. So on this problem here, our first step is to isolate y. But it's already isolated for us. You're welcome. So we can leave it as it is. So we just go straight to step 2, which is to plot the y-intercept. So since this is in slope-intercept form, we can see that b is negative 3. All right, and then we plot that negative 3, 0, negative 3 on our axis here, or on our graph, right about there. And then we have to use our slope to plot the next point. So here our slope is 4/5. So that means my rise is 4. I'm going to go up 4 from this point, and then to the right 5. And we plot a point. All right, and since we have a greater than or equal to sign, I need to use a solid sign, or solid line on this graph. So we will choose a solid line. All right, and then the last step is to shade over or under. So we have a greater than or equal to sign. So since it's greater than or equal to, that means we are going to shade above the line here. So let's shade above our line. Okay. And let's just quickly talk about some solutions here. So I'll plot, let's see, 5, negative 5, and let's do 2, 0. All right, so looking at 5, negative 5, I want you to put, is it a solution or is it not a solution? And then look at 2, 0. Is it a solution or is it not a solution? So I'm going to give you a few seconds to write that down. Okay, I can't handle the silence anymore. So 5, negative 5. This is not in the, it's underneath the line, so it's not in the shaded portion, meaning it is not a solution to this inequality. So great job, if that's what you put. And then the next one at 2, 0, it's above the line, and it's in that blue shaded area. So 2, 0 is a solution. All right, so hopefully you can see how to find a solution, or how to find an example of a non-solution. So you just, for when you're looking for a solution, you're looking at any point that is in the shaded area. Or in a case like this, when there's a solid line, you could pick a point that is directly on the line if you have a greater than or less than or equal to inequality. So just like that. But if it's a dotted line and you have a point on the dotted line, it would not be a solution. All right? So that is all we have today for our notes. And now there's a class kick. And the whole class just roared out for an applause because they're so excited about this class kick. This class kick is very similar to what we did just now in our notes. You will be following those 5 steps, isolating y, plotting the y-intercept, using rise over run to find the next point, and then drawing a solid or dotted line, and then shading over or under. Once you do that, it's going to ask you for 2 solutions and 2 non-solutions. And so you will just be writing a point, 2 points that are in the shaded area and 2 points that are not in the shaded area. All right, so good luck. And ready, set, go, class kick.